Now this illustration deals with sizing the conductors to a capacitor bank. Now notice this capacitor bank is three-phase, 208 volt, 25 kVA. We're not dealing with microfarads here, but we know, or I can tell you, that if you will go and review what the Note 1 and Note 2 says, the capacitor is connected on the load side of the controller. That means the controller with its overload protection and so forth is protecting this capacitor and with its conductors. Section 460.8a requires the largest conductors calculated, which are 3 AWG THH copper conductors, which would be step 5, I believe, in the calculation, as we will review how the calculation is made. Now notice the controller is sized by 430.83, also 430.81. The disconnect for the location is 430.102, 430.109A1, and 430.110.8. But if we apply 430.57, fuses in a disconnect complying with 430.55 can protect that controller and that capacitor. And if you want the macrofarads shown, as well as selecting the size capacitor and conductor based upon correction factors for power factor, look at the figure 18-56 in volume 2 of Stallcup's design book. To get a good design, installation, and inspection, as well as maintenance, using a book, I suggest you use and get Stallcup's volumes 1 and 2. I have spent a lifetime developing the information in this book to aid designers, electricians, and inspectors, because as you know, I've been both, all three really. So keep that in mind. It's available to you if you wish. Now, with that thought in mind, let's move to the next illustration and see the two-method procedure that's required to calculate the size of those conductors from the controller to the capacitor.